So now we're going to look at how we can find different derivative functions. So rather than just finding the derivative at a point, how do we find the derivative of that function overall? So like in the last video, we found the derivative of x, the square root of x at x equals 4. So now how would we go about finding this purple line right here, right? Like, what is that function? How do we find that function? So let's start with that one, and let's just see what we end up getting. Okay, so maybe not one of the easiest ones to start with, but why not? And it should be pretty much the same process. Okay, so the limit as h approaches 0 of f of x plus h, so the square root of x plus h, minus f of x over h. So again, we're just going to want to multiply by the conjugate here. Whenever we see these roots, that's pretty much what we're going to need to do. Okay, so this is going to be the limit as h approaches 0 of, so this is going to be x plus h minus x, okay, just by the difference of squares formula. So you have x plus square root of x plus h squared, which is x plus h, minus square root of x squared, which is x. Okay, and then this is going to be over h times the square root of x plus h plus the square root of x. Okay, so now the x's here cancel. So we're left with the limit as h approaches 0 of h over h square root of x plus h plus the square root of x. Now these cancel, so there's just a 1 left on top. And then we can go ahead and plug in the 0 for h now. We can take the limit of this as h goes to 0. So we'd have 1 over the square root of x plus the square root of x, which is 1 over 2 times the square root of x. Okay. So that is what this purple line is right here. In fact, if we let's just go ahead and put that in, 1 divided by 2 times the square root of x, we can see it is that exact same line, right? We can go ahead and change that to purple as it was before. Or if we just do g of x equals f prime of x, we can see they're overlaid on top of each other, right? So these are the same line. So let's go ahead and try some other ones. So maybe we try a polynomial function. So like x squared, for example. Right, we've already seen this at a certain points, but we haven't actually seen what the overall derivative function would be. So the limit as, oops, I keep putting x, h approaches 0 of f of x plus h, so x plus h squared, minus f of x over h. So we go ahead and try to simplify the top here. So this is x squared plus 2xh plus h squared minus x squared over h. So the x squareds cancel out, and we're left with the limit as h approaches 0 of 2xh plus h squared over h. So again, we can cancel an h out of everything because there's 1 in every term, right? So we get the limit as h approaches 0 of 2x plus h, which is just going to be 2x. Okay. So 2x is the function which describes the slope at any point of x squared. So the slope at 1 is 2, the slope at 2 is 4, the slope at -8 is -16. Okay. Okay, let's try something a little bit, I'll take a little bit more work maybe. What about x cubed? Okay, so we want the limit as h approaches 0 of x plus h cubed minus x cubed over h. So this one will be a little trickier. We'll do the limit as h approaches 0 of, there's a formula to just expand the whole thing, but let's just do it piece by piece here. So this is x plus h times x plus h squared, which we just found in the last one, minus x cubed over h. So now we go ahead and multiply that whole thing out. So x times x squared, we get x cubed plus 2x squared h plus xh squared. So I multiplied x by every term. Now I multiply h by every term plus hx squared. It's probably better to be consistent and always put the h as second or put the x as second. It doesn't matter really, but just so we can see which terms might cancel out. So now plus, or combine, plus 2x h squared plus h cubed. And then we have a minus x cubed, all over h. Okay, so what cancels, if anything? So x cubed and x cubed cancel out. We have two x squared terms. So here, let's go ahead and write down everything. Okay, so we have 2x squared h and x squared h, which will give us 3x squared h. We have xh squared plus 2xh squared, which will give us 3xh squared. And then all that's left is h cubed. Okay, so now again, everything has an h in it, so we can cancel an h out of everything. Okay, so this is how I like to write the canceling out. Just kind of cross out the exponents and bring it down by 1, right? H cubed over h is h squared. So now we have the limit as x approaches 0 of 3x squared plus 3xh plus h squared. So this term is going to be 0, this term is going to be 0, and this one doesn't have an h in it. So we're just going to be left with 3x squared. Okay. And then we're done. Okay. Okay. So let's just do one more here. Let's try the f of x equals 1 over x. Okay. So one thing to keep in mind here is that we already know that the limit does not exist at 0. So therefore the derivative is not going to exist at 0. So in other words, when we're going to get a function such that the domain is not going to have 0 in it. And actually, now that I'm thinking about it, I didn't mention that for the square root function either. So we should look at that real quick. And we'll get into this a little bit more later about the relationship between continuity and differentiation. But this function also, there is the derivative of the square root of x. It doesn't exist at 0, right? It's not in the domain of 0. This is consistent with what we were talking about. Really, actually, that was all the way in Math Tools 1, but in the limit videos there, about how the limit of this function does not exist at 0, only the right-hand limit does. So the left-hand limit of this at 0, I should say, does not exist. So the derivative of this function at 0 does not exist. And that's confirmed by the fact that 0 is not in the domain of our derivative function. Okay. So we should expect the same thing here. We should expect the derivative the limit doesn't exist at 0, therefore the derivative doesn't exist at 0, so we expect that it won't be in our domain. So let's go ahead and look at limit as h approaches 0 of 1 over x plus h minus 1 over x over h. So we'll find a common denominator here. So that means we'll multiply this by x plus h over x plus h and this by x over x. Okay. So we're going to get x minus h over x times x plus h all over h. And we're still taking the limit as h approaches 0 of this. Okay, so we just found a common denominator for the two fractions on the top. Now, two things to note. One, x's cancel here, so we just have negative h on the top. Second, we have a fraction divided by h. So this is really going to be the limit as h approaches 0 of negative h over x plus h times 1 over h, right? We multiply by the reciprocal. And in the process there, these h's cancel. So we get the limit as h approaches 0 of negative 1 over x times x plus h. Okay, so h is going to 0 here. So this is going to be negative 1 over x times x, which is x squared. So negative 1 over x squared. And 0 is certainly not in the domain there, so it is consistent with what we know about the limit existing.